Alright, so let's talk a little bit more about payloads then. Let me go back out of this one and let's use a payload for Windows for a binding TCP shell. So I'll start typing use payload. I know I want Windows. I'm doing tab complete on these. And I'll start with shell. And we get bind TCP. Alright, so if a binding TCP shell means that I'm going to be bound to a port, and I should be able to get a shell, command shell on that Windows system when this actually connects. One of the things that you'll find when you're doing this kind of work is that you need to frequently generate shell code, because your payload as is will get detected by antivirus, and that's going to stop your pen test in its tracks. So we have a command called generate. Once you're within a payload or an exploit or a module, you can use the -h command to get help information. I can use help by itself, of course, like I showed earlier, and you'll notice that the generate command is within the payload category. So I'll do generate -h to see what my options are. And I can see that I've got some encoding options here. So I can force the encoding. I can tell it to avoid certain characters. We'll see what that looks like here in a minute. I can tell it how many iterations to perform, because the more times I encode something, the more likely it is to remain undetected. That's the theory anyway. I can also specify the size of the NOP sled. There's lots of different options. And then a lot of different output formats. See, I got quite a few different categories. Perl, Java, PowerShell, Raw, Ruby, Visual Basic Script. So there's lots of different possibilities there. All right, so the first thing we're going to do is just do a generate command without any options, without any arguments. And you'll see I've generated shell code for this shell bind TCP payload that I'm using. Now you can see it gives me some parameters. I can see how many bytes the payload is. It's 328 bytes. I've got my local port specified. The remote host is not specified, but obviously you would want to prepare those settings during the process of building your payload. So for instance, I could go back and do a set G for my remote host. Show my options. I can see where my remote host is now set. Now if I run the generate command again, I'll see that is encoded in the payload. So there it is. It knows what my local host is, my local port is, and I've got some kind of shellcode that I could try to use as a payload when I get connected to a victim system. But there might be certain bytes in this payload that are known to trigger the antivirus. And I'm just going to randomly pick something here. So the process of figuring out what those bytes are is a little bit beyond the scope of what we're doing. But the basic idea is that you would try to take your payload and analyze it and see what portion of it is actually triggering a signature on an IDS. Maybe I know that this XFF hex code here is part of the problem, and I might want to get rid of this. I want to filter it out and replace it with something else in order to try to get my shellcode past the antivirus. So I can run the generate command with the -B, because we saw that earlier. I'll do the -H again. The -B says these are the characters to avoid. -B, and I'll do I'll just use the ones that I see here. I've got XFF, which I want to get rid of. I also want to get rid of, let's say, X50, because those are both problematic. Now you'll notice that my payload size is different. It's 350 bytes. Previously it was only 328. If memory serves, there it is. And you'll notice I had an X50 at the end of the first line before. Now that X50 is gone, and I shouldn't be able to find X50 anywhere in here. I also should not be able to find XFF. Previously, it was somewhere, there it was. So now that I filtered that out, it replaces it with other shellcode which provides that same functionality. So that's why the size of the payload grew a little bit, because I needed other codes to compensate for the fact that I removed these two from the payload. Other things to think about would be you could certainly generate a much longer list. I could remove, let's say, all of these opcodes, or these parts of the shellcode. And if I do this now, actually my size did not change. It still stayed 350 bytes, which is unusual. I thought it would probably have gone up. But you get the basic idea. You're able to filter out a lot of these byte codes that may be problematic. Now, if you go too far, and I'll show this as an example, you might say, well, I've got so many that I need to get rid of. I'm just going to pick this entire line. And that actually worked. If you do too many, though, you may get an error message that says that you cannot generate the payload. And that basically means that you've tried to eliminate too many of the shellcode options that you've got available to you. And now the software can, the Metasploit encoder, when it's generating the payload, cannot basically put that together. So there's limits to how far you can go with removing objectionable bytes from your payload. All right. So another thing we want to look at is the encoders themselves. So within this shell bind TCP, I can do a show encoders, and I can see all the ones I've got available to me. Some of these are excellent, like PowerShell Base 64 or Shikata Ganai. So again, we get a little description here: polymorphic exclusive or additive feedback encoder. That sounds impressive, and what it means is that there are ways to make your payload less likely to get detected. There's also other things, like, for instance, we can say we want a non-alphanumeric encoder, or one that doesn't use any upper characters, so non-upper. There's lots of different choices here for customizing your payload for the task at hand. So, for instance, maybe I want to use the non-alpha as an example. Actually, I don't want to use the, I'll use the Shikata encoder instead. So I can go ahead and run my generate command again. Now this time I'm going to use the -E for encode, and I can type it doesn't like that. I'll use my copy and paste. Tab complete usually works, but there might be certain instances within the framework where it doesn't work, so just be aware of that. All right, so now I use this encoder, and it tells me 355 bytes for this shell bind TCP for Windows. There's my encoder, my local port, my remote host. These are all part of the payload now. But I can also do compound statements. For instance, I know I don't want the XFF, and I don't want X50. All right, so I can make sure I can get rid of those. So I can add multiple options to the command line. If we go back up to our help screen, we can see for generate, we also have ways to, I can specify my standard output if I want to save this information. I can use templates. I can also pick the number of iterations. So let's experiment with that a little bit. I've got the encoder. I'm going to get rid of these two characters. Let me add one more to the list. I'll get rid of X Charlie 9 because I see that at the corner of the table there. All right, let's encode again. Oh, I got an error. So I can't get rid of that many characters. Let's just try these two. It's being kind of picky. All right, so I can only get rid of XFF. That shows you some of the limits of what the encoder is capable of doing. So what do we end up with? 355 bytes. Now what if I want to encode this a few times to make it more complex? I can encode it 3 times. And you'll notice that it doesn't actually give me 3 outputs. It does it 3 times and then I get the output. It grew quite a bit. Now it's up to 409 bytes. But still, I've excluded XFF, and I'm still using this particular encoder. And again, this multiple passes that you're doing with the -I makes your encoding that much more difficult for the antivirus of the victim machine to detect. And there are probably limits here as well as far as what kinds of, or how many iterations you want to go through, or some of the other things that you'd want to set. So let's go back to our help screen. We can see we've got the -O option. So because I know some of my options are available here, I can do something like, I'll do up arrow, go back to my generate. Let's say I want to change when I'm doing my generate, I want to change my local port to something else. So I'll change it to 5555. Possibly it is, oh, I forgot to put the equal sign, that's why. Okay. So, little details matter. We can see now that it went down to 409 bytes, still showing my encoder. My local port is now 5555 because I've encoded a different version of this. So this goes to show you how flexible the syntax is. I can change my encoding method. I can change the number of times I do the encoding. I can set some of my variables and encode a payload all in one step, which makes your life a lot easier when you're trying to evade antivirus. And lastly, let's look at our -T option. This gives us our output format. So bash, C, C#, hex, Java, and so on. I got a lot of different payload options. So we can experiment with this. Got my last command there. Let's say I want to do this in bash format. So that's what bash shellcode looks like. You know, it's a little different. I've got some $signs here. The characters look a little bit different perhaps. Let's see, I can try one with PowerShell. Oh, didn't like PowerShell. Maybe I can try C#. All right, so there's a different encoding method using C#. So you get the basic idea. I've got lots of options, and you've got other things here that might be useful depending on your environment that you're going after. Maybe a Visual Basic script, or you're dealing with binaries, EXEs. So just kind of showing some of the possibilities for your AV avoidance. And we'll get into more detail about that in a later section.